Let's look at the solutions for quality quant questions. Week 28, questions related to probability. We are nearing the end of this series. A box contains 10 cards. 7 of these cards have the letter I printed on them, and others have letter M printed on them. If 3 cards are picked up one after the other at random and are placed on the table in that order, then what is the probability that the word IIM is formed? Okay. So what we want is the first letter has to be an I, and the probability of that is 7 by 10. The second letter should also be an I. Probability of that is 6 by 9. Because one I is already gone, there are 6 I left out of 9 letters. And then the third letter has to be an M, the probability of which is 3 by 8. And we have to simplify this. Okay. So first thing I can get rid of 6 into 3. So this will become 2. This 2 goes away with 8. Finally, we get 7 by 40, or option B is the right answer. Next, a bag contains 4 5 rupee coins, 3 2 rupee coins, and 3 1 rupee coins. Okay, if 6 coins are drawn from the bag at random, what are the odds in favor of the draw yielding maximum amount? For yielding maximum amount, all the 4 5 rupee coins should come. All the 4 5 rupee coins should come. And 2 3 rupee, sorry, 2 rupee coins should come. The probability of getting 4 5 rupee coins will be given by 4 into 3 into 2 into 1. Whole thing by 10 into 9 into 8 into 7, and then 2 rupee coins will be 6 are gone. So 3 into 2 by 6 into 5. But pay attention, pay very close attention. The order in which these 6 coins come, that is not certain. They can come in any order. And in how many orders can they come? That is 6 factorial by 4 factorial into 2 factorial. So this will be the probability of yielding the highest amount. Probability of yielding the highest amount. So we have to solve for this. Now we have 4 factorial will get cancelled with this entirely. 2 factorial with this entirely. 10 into 9 into 8 is already 720. So this will also go away with 6 factorial. So we are left with 7 into 6 into 5. I can cancel this also. And the probability is 1 by 70. But finally, the answer asked of us is not probability, it is odds in favor. And odds in favor is given by favorable outcomes by unfavorable outcomes. Favorable outcomes, the probability of that is 1 by 70, and probability of unfavorable outcomes is 69 by 70, or the final answer will be 1 by 69, or option B is the right answer. Okay. Next question. A cube has 4 of its faces blank. One face is marked 5 and the other is marked 6. In a game involving throwing this cube, a person is said to have success if he throws a numbered face. So probability of success is 1 by 3. Out of 6 faces, 2 faces have numbers marked, and 2 faces have numbers marked and 4 are empty. 2 persons A and B participate in the game. A throws the cube thrice and B throws it once. Find the ratio of A's chance of success to that of B. Okay, A's chance of success is, if he, from the total probability of 1, if he does not succeed in getting any number in any throw, and that is given by 1 by 3 whole cube. This is probability of A success. This is probability of a success will be equal to 1 minus, oh, this will be 2 by 3. Probability of success is this. So 1 minus 8 by 27. This will be equal to 19 by 27. Probability of success for A is 19 by 27. And probability of success for B, because he's only one, he has only one throw, it will be 1 by 3. So we are looking at probability ratio of A's chance of success and B's chance of success. The answer will be 19 by 27 is 1 by 3. Cancel, 9. Or the final answer we get is 19 is to 9. Or option A is the right answer. Okay. Next question. A bag contains 6 red and 4 white balls, and another bag contains 5 red and 5 white balls. If one of the bags is selected at random and a draw of 2 balls is made at random from the bag thus selected, what is the probability that both the bag balls are white? Okay. Probability of selecting the first bag is half. And then both the balls be white, the probability will be 4 by 10 into 3 by 9. Or we end up selecting the second bag, probability of which is 1 by 2. Probability of the first ball being white is 5 by 10. Probability of the second ball being white is 4 by 9. And we have to simplify this. We get 12 plus 20 by 180 or 32 by 180. If I cancel the numerator and denominator by 4, I get 8 by 45, or option B is the right answer. Next, if a square is selected at random from an 8 by 8 chessboard, what is the probability that it is a 3 by 3 square? Now, for an 8 by 8 chessboard, getting a square of size 8 by 8, there is one such case. Getting a square of size 7 by 7, there are 2 square such cases. For getting a square of size 6 by 6, there are 3 square such cases. And 5 by 5, there are 4 square such cases. For a 4 by 4, there are 5 square such cases. If you want to know how these cases are being generated, you can look at the last video on PNC, where I got into detail of how the square counting, or for a chessboard, how counting happens. 3 into 3, there will be 6 square cases. For 2 into 2, there will be 7 square cases. And for 1 into 1, there will be 8 square cases. So, a square is being selected at random from an 8 by 8 chessboard. These many squares are there. Summation of these is sum of first 8 natural numbers. Sum of first 8 natural numbers square. So that is given by 8 into 9 into 17 by 6. 12, which is 204. This number 204 gets tested very often in placement papers. So anyone who is preparing for placements as well, you can perhaps memorize this number. 1296 is the number of rectangles, 204 is the number of squares on the chessboard, standard chessboard. Now, probability that it is a 3 by 3 square. Favorable cases are 6 square, and total cases are 204. So, we will get how much? We can cancel off 12 entirely. We have 3 by 17 left, or option B is the right answer. Next, Kiran rotates a roulette wheel which has markings from 201 to 300. So 100 possibilities are there. If the wheel stops at a multiple of 7, he wins 7,000. If the wheel stops at a multiple of 13, he wins 13,000. And if the wheel stops at a multiple number, which is a multiple of both 7 and 13, he wins 91,000. If Kiran has to pay an amount of 2,700 every time he rotates the wheel as a participation fee, then in the long run, what is the average profit he makes per game? Okay. Multiples of 7 in this range. I know 210 is a multiple. So first multiple of 7 will be 203, 210, 217, 224. If you want to jump directly to the last term, it will be 299. These are the multiples of 7. which is 7 into 29. This is, sorry, this will not be 299, this will be 294. This is 7 into 42. So we have 14 such cases here, multiples of 7. 14 multiples of 7 we have. Similarly, we'll list out the multiples of 13. I know 195 works, so 208 will be the first one. And we keep on going till 299. This is 16 into 13. And this is 23 into 13. So here we get 8 multiples of 13. But there is also a number with multiple of both 7 and 13. If you're a multiple of 7 and 13, you're a multiple of 91, there LCM. Multiple of 91 within this range is only one number, 273. One multiple of 91. Now see, because this is a multiple of 13 also, this is a multiple of 7 also, the outcomes, the cases where you get multiples of 13, that will reduce to just 7. Now 7 multiples, one of the numbers in between is going to be 273, which has a different outcome. This will not be counted in this list. Very similarly, here also, there is going to be a number which will be counted here. It will not be counted here. So we have 13 multiples of 7 alone, but not of 13. 7 multiples of 13 alone, but not of 7. And 1 multiple of 91. Now, if he gets a multiple of 7, he wins 7,000. So his earning will be 13 into 7,000. In this case, if he gets a multiple of 13, he wins 13,000. So his earning here will be 7 into 13,000. There is just one case, 1 into 91,000. Thankfully, you will see all three of them individually are 91,000. So overall earning is 27,000. Sorry, 2,73,000. The overall earning is 2,73,000. Now, Kiran is paying an amount of 2,700 every time he rotates the wheel as a participation fee. So, this is the potential earning in 100 throws. This is the potential earning in 100 throws. His cost is going to be 2,700 into 100 or 2,70,000. 2,70,000. So, how much is he earning? On an average, how much is he earning over 100 throws? It is just 3,000. He's earning 3,000 over 100 throws. Then, over 100 throws, if he's earning 3,000, per throw, he will earn a grand total of 30. In the long run, what is the average profit he makes per game? He will make 30 rupees per game. Okay. Next, a pair coin is tossed 10 times. What is the probability of a tail occurring as many times in the first 6 tosses as in the last 4? Okay. So for the first 6, the last 4, we can have 0 tails, 6 heads, 0 tails, 4 heads. We can have 1 tail, 5 heads, 1 tail, 3 heads. We can have 2 tails, 4 heads, 2 tails, 2 heads. We can have 3 tails, 3 heads, 3 tails, 1 head, and finally 4 tails, 2 heads, and 4 tails, 0 heads. So this should happen, and this should happen, or this should happen, and this should happen. So we have to find out probability of each of these lines. Probability of the first thing is 1 by 2 raised to the power 6 into 1 by 2 raised to the power 4. This is for the first case. Second case, I will write here so that I have enough space. Again, see, here, this can happen in 6 ways. Where that tail is coming, out of the 6 possibilities, where that tail is coming, that can be identified in 6C1 into 1 by 2 raised to the power 6 into, here that tail can come in 4c1 base, 4c1 into 1 by 2 raised to the power 4. Absolutely wonderful. Which should now tell you 1 by 2 raised to the power 6 and 1 by 2 raised to the power 4, overall of 1 by 2 raised to the power 10. That will be common all across. So all we care for is how many times these iterations would take place. 6c1 into 4c1. There is going to be one case of this. There is going to be 6c1 into 4c1. 24 cases of this. Then from here we'll get 6c2 into 4c2, which is 15 into 6. 90 cases of this. Then here 6c3 into 4c3. So 20 into 4, 80 here. And from here, 6c4 into 4c0. So 15 cases of this. These many cases are there. And all of that, and this, their summation has to be multiplied by 1 by 2 raised to the power 10. I have 1 by 2. For 1 by 2 raised to the power 10, I can directly write as 1 by 1024 into sum of 1 plus 24 plus 90 plus 80 plus 15. Now 1 and 15 will add up to give me 16. 16 plus 24 will add up to give me 40. So I have 40 plus 80, 120, 120 plus 90 is 210. So we get 210 by 1024. I can cancel off the 2, get to 105 by 512. And that should be the answer to this question. Option B. Next, 3 men shot at the same target. The probability of the first, second, and third man hitting the target respectively is 0.3, 0.5, and 0.6. Find the probability that exactly one of them hits the target. So, probability of the first man hitting the target is 0.3. Probability of the first man missing the target is 0.7. Probability of the second man hitting the target is 0.5. Probability of the second man missing the target is also 0.5. Probability of the third man hitting the target is 0.6. Probability of the third man missing the target is 0.4. If exactly one of them hits, first case is the first guy hits, it will be 3 by 10 into 5 by 10 into 4 by 10. This is when the first guy is hitting. The second case is second guy is hitting, which is 5 by 10. And the other two guys are missing, which is 7 by 10 plus 4 by, not plus, into 4 by 10. And finally, third guy is hitting 6 by 10, and the first two guys are missing 7 by 10 into 5 by 10. The denominator everywhere is 1000, so we'll keep that as 1000. Numerator 3 into 4 into 5. 3 into 4 into 5 adds up to how much? 60. Then I have 5 into 4 into 7, 140. Then I have 6 into 7 into 5. So this will give me 210. 30 into 7, 210. So this becomes 410 by 1000. Cancel, cancel. We get 41 by 100. Option A is the right answer. Next, the odds in favor of a player being selected for the national team, the 3 independent selectors are 4:3, 2:1, and 1:4 respectively. So, probability, see, these are odds in favor. So, probability of the first guy getting selected is 4 by 7. Probability of the second guy making that selection, second selector making that selection is 2 by 3. And the probability of the third guy making that selection is 1 by 5. Favorable by some of these ratio points. What is the probability that of the 3 selectors, a majority will be favorable? If a majority is supposed to be favorable, first thing I'll have to do is also figure out probability of being rejected by this fellow is 3 by 7. Probability of being rejected by the second guy is 1 by 3. Probability of being rejected by the third guy is 4 by 5. Now, if you are looking for majority, one case is all three selectors end up selecting you. So you will get 4 by 7 into 2 by 3 into 1 by 5. All three selectors have selected you. Then just one selector rejects you, the other two accept you, and there will be no other cases. Either all three selectors select you, or at least two selectors select you. So I'm saying the first two select, the third reject. So I'll have 4 by 7 into 2 by 3 into 4 by 5. Now, the first and third select, the first and third select, third one rejects. 4 by 7 into 1 by 5 into 1 by 3. Final case, second and third select, first one rejects. So 2 by 3 into 1 by 5 into 3 by 7. Again, if you look at the denominator, everywhere it is going to be 105. I have 8 plus 32 plus 4 plus 6, or overall we get 50 by 105 as the probability. We can cancel off the 5 to get to 10 by 21, and that is option B. That is the answer to this question. Next, Sadiq, Akhil, Afroz start a game of dice. They throw the dice by turns. First Sadiq, then Akhil, then Afroz, then once again Sadiq, Akhil, Afroz, and so on until one of them wins. Sadiq is considered to have won if he throws an odd number. Akhil if he throws a prime, and Afroz if he throws an even number. What is the probability that Sadiq wins? Okay. Probability of win for Sadiq. Sadiq, if he throws an odd number from the first 6, 3 numbers are odd, so probability of his win is half. And probability of his failure is also half. Probability of Akhil's win is if he throws a prime number. Within the first 6 natural numbers, prime numbers are 2, 3, and 5. 3 numbers again. So probability of Akhil's victory is 1 by 2. And probability of Akhil's loss is also 1 by 2. And finally, Afroz's victory, probability of that is again 1 by 2, because 2, 4, 6 are 3 numbers. The probability of Afroz's loss is also 1 by 2. Now, given that Sadiq throws the dice first, you can directly come to the answer. Probability of him winning overall is going to be higher than 50%, or it is going to be highest among all the other probabilities. His probability will be highest among all other probabilities, or higher than 50%. And utilizing that, you can directly come to option B. This is the only one where the probability is greater than 50%. Otherwise, if you want to calculate it precise mathematically, you can see either Sadiq wins. In this case, he wins. Another case, he wins. First time Sadiq loses. Then Akhil loses. Then Afroz loses. And then Sadiq wins. Another case could be Sadiq loses, Akhil loses, Afroz loses, Sadiq loses again, Akhil loses again, Afroz loses again, then Sadiq wins, and so on. Multiple cases can be generated. The probability of this first line of event happening is simply half. The probability of this second line of event happening, half into half into half into half, is 1 by 2 into 1 by 2 raised to the power 3. The probability of this third line of event happening is 1 by 2 into 1 by 2 raised to the power 6. And if we keep on continuing writing it down, then you see this will turn into an infinite GP. There is an infinite GP where the first term is half and the common ratio is 1 by 2 whole cube, or 1 by 8. Summation of this infinite GP is given by A by 1 minus R, which is equal to half by 1 minus 1 by 8, which is equal to half by 7 by 8. This 2 comes down, this 8 goes to the top. I'm left with 8 by 14, which is equal to 4 by 7. Or the precise answer to this question is option 1. Okay. Next question. A bag contains 3 white, 5 blue, and 4 green balls. If 2 balls are drawn at random from the bag, find the probability that both the balls are of the same color. Okay. The balls have to be either white, or they have to be blue, or they have to be green. There are 12 balls in total. The probability for white will be 3 by 12 into 2 by 11. For blue, it will be 5 by 12 into 4 by 11. For green, it will be 4 by 12 into 3 by 11. So 6 plus 20 plus 12. 6 plus 20 plus 12. We get 38 by 132. We can cancel off 2. Get to our final probability of 19 by 66. Or option C is the right answer. Okay. Next. Kiran selects a numbered card numbered from 101 to 2000. If the number on the card is a multiple of 8, but not 12, he wins 40. Okay. Let's, given that but not 12 is specifically mentioned, let's list out all multiples of 8 in this range. It will start at 104, 112, 120, 128, 136, 144, 152, 160, 168, 176, 184, 192, and 200. Now from these, I have to first try and find out only multiples of 8, but not 12. This is a multiple of 12, so rejected. This is a multiple of 12, so rejected. This is a multiple of 12, so rejected. And this is a multiple of 12, so rejected. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 multiples of 12, 9 multiples of 8 that are worth considering, that are also not multiples of 12. And in these cases, he wins 80 rupees. No, he wins 40 rupees. Sorry. He wins 40 rupees. Okay. Then if the number on the card is a multiple of 12 and not 8, he wins 65. Let's list out all multiples of 12 in this range also. 108, 120, 132, 144, 156, 168, and 180 and 192. But from this, I have to remove numbers that are multiples of 8. I have to remove the same numbers that I had identified here. The same numbers will get removed here also. So in this range, I get 4 numbers, 1, 2, 3, 4, 4 multiples of 12. And when we get such a number, we get 65 rupees. If the number on the card is a multiple of both 8 and 12, those numbers are 120 and 144 and 168 and 192. 4 multiples of 8 and 12. Here we get 80 rupees. Okay. In the long run, what is the amount Kiran will gain on an average if he has to pay 3.6 as participation fee for each draw? So his total cost, given that there are 100 numbers, his total cost will be 360 rupees. For 100 throws, if all the outcomes are equally likely, his total cost will be 360 rupees. And his earnings will be 9 into 40, which is 360. 4 into 65, which is 260. And 4 into 80, which is 320. His earning will be 0.0000662 over 1 carried over 940. In 100 throws, he ends up earning 940. He ends up expending 360. So his profit will be 580. His average profit over 100 throws is 580. But they're not looking for average profit over 100 throws. They're looking for his gain on an average, which is per draw. So it will turn out to be 580 by 100, or the final answer is 5.80. Okay. Next, Raghavendra draws a card from a pack of cards. If the card is a red honor, okay, honor cards are A, K, J, Q. Basically, non-number cards are known as honor cards. The card is a red honor. He is paid 65. Now, see, red honor, there are two suits within red. One is diamonds, one is hearts. So, 4 cards per suit. Or total, we have 8 cards here. 8 cards giving 65 rupees. So, 8 into 65 earning. While if it is a blackjack, now, black, there are two suits. There is clubs and there is spades. So these are 2 cards being referenced here. 2 into 52. His earning is this much. In all other cases, he has to pay 26. In all other cases, he has to pay 26. Pay attention. For 8 cards, he earns 65. For 2 cards, he earns 52. 10 cards are taken care of. And from a card from a pack of cards. A pack of cards usually have 52 cards. 10 are gone. So, for the remainder, 42 outcomes, he has to pay 26. So, this is his overall gain loss over 52 outcomes. So, in the long run, per draw, Raghavendra makes an average. Okay. Per average, per card, per round, per draw, if we need the average, we divide it by 52 straight away. So 52 is gone from here. 26, this will become 21. 65 and 52. 52 will get cancelled, of course. This will become 5. So 4 will be left. This will become 2. So I will have 2 into 5, 10 plus 2 minus 21. Or he will get minus 9 per draw. He will get minus 9 per draw. Or the correct answer to this question, loss of rupees 9 per draw he will get in the long run. Next, 30 students of a class were asked to prepare one project each. Each project was to be assessed by 2 professors, namely Don and Ron. Don usually rejects 40% of the projects he evaluates. So probability of acceptance from Don is 60%, or let's say 3 by 5, and probability of rejection from Don is 2 by 5, 40% rejection rate, while Ron accepts only 40% of the projects he evaluates. So probability of acceptance from Ron is 2 by 5, and probability of rejection from Ron is 3 by 5. When a student gets his project evaluated from both the professors, what is the probability of getting a rejection from both? We simply need a product of these two numbers. So we have 2 by 5 into 3 by 5, which gets us to 6 by 25, which is equal to 0.24, or the correct answer is option C. Next, Ramesh has a special set of cards for a new game he invented. He has 2 packs of 6 cards each, with their values ranging from 1 to 6. So this is essentially 2 dices only. Even though we are calling it cards, there are, for a dice, you have 6 outcomes, 1 to 6. Here also 2 packs of 6 cards, values ranging from 1 to 6. It is not that different. In that game, Ramesh shuffles the cards of both the packs, that is 12 cards, and draws 4 cards. He tries to find any pair with the same value. What is the probability that there is at least one pair? What is the probability that at least one pair will have same value? Okay. So from 12 cards, he has picked up 4. 12 cards, he has picked up 4. I'm saying the first card, whatever he picks. What I'm going for is 1 minus no pair. I'm looking to calculate 1 minus no pair. So first card, whatever he picks. Now for the second card that he picks up, he should he should not be having the what is it? He should not be getting the pair card of that. So out of 12, one card is gone, 11 cards are left. The pair card of that should not be picked up. So no pair probability is 10 by 11. Now he has got cards of two distinct values. The third card he picks up should not be pairing with the first card, should not be pairing with the second card. So four cards are gone. 8 options are left. 8 by 10. And in the same way, you will have 6 by 9. And this is it. This is it. See, first card, whatever. Let's say he picks up first card that is picked up is the number 4. Now the second card, what all can be picked up? Apart from 4, the other 10 cards can be picked up so that no pair gets gone. So we'll have an option of 1, 2, 3, 5, 6. 1, 2, 3, 5, 6. The second pick, you end up picking one of these 10 cards so that a pair does not get. Let's say 3 was picked up here. So in your third pick, now what all options are left for you? 1, 2, 5, 6. 1, 2, 5, 6. You only want cards from within these 8 now, because then again a pair will not get made. And then here, fourth, let's say in the third round, in the third pick, 6 was picked up. Now you don't want a 4, you don't want a 3, you don't want a 6. So the only options left are 1, 2, 5, 1, 2, 5, 6 out of the remaining 9 cards. Here the total availability was any card out of 12, so it doesn't matter. Here 11 cards are available. Here 10 cards are available. Here 9 cards are available. So this works out. Now when we solve this further, we also have to take into account. The fact that these 4 cards that have come in, they can come in any order. These 4 cards that have come in can come in any order. But do I care about the order? No, I've picked them one after the other, so it doesn't really matter. So I can take care of this straight away. This will become 2, this will become 3. I get 16 by 33. This is the probability of no pair. This is the probability of no pair. If the probability of no pair is 16 by 33, then my final answer, which was 1 minus probability of no pair, will be 1 minus 16 by 33, which is equal to 17 by 33. Or option B is the right answer. Okay. Now, a fun way to solve this. Hopefully, you realize out of 12 cards, you are picking 4. So 11 will definitely be in the denominator. 11 will definitely be in the denominator. This does not have 11. This does not have 11. This does not have 11. This has an entirely new prime number. This has an entirely new prime number. This has 7 in the denominator. These are not possible at all. Among the available options, the only option that can potentially make mathematical sense is option B. You could have, if you are comfortable with numbers and you can see factors and multiples, perhaps you could have marked your answer even faster then. Okay, next. You buy 20 eggs from the market, of which 2 are rotten. You randomly pick 4 eggs to prepare scrambled eggs for breakfast. If any one of the 4 eggs are rotten, then it will make the breakfast uneatable. What is the probability that the breakfast turns out to be uneatable? Okay. So we again do 1 minus eatable breakfast. So 1 minus the first egg is 18 by 20. Second egg is 17 by 19. Third egg is 16 by 18. And the final egg is 15 by 17. 1 minus this, 18 and 18 gone, 17 and 17 gone. This becomes 5. This becomes 4. We get 1 minus 16. Oh, I can further reduce this. 1 minus 12 by 90, or the final probability is 7 by 90. But options are given in decimals, so we'll have to divide. 7 divided by 19, 0, 0, gets me to 3. Makes a lot of, as in, pushes us towards option A. But we have to be entirely certain that is the case. 130, so 19 into 6, 114, 160, so 8, 152, 80, gets me to 4. So 0.368 is fine. Answer is option A. Next question. A bag contains 6 red marbles and 4 blue marbles. If a marble is drawn with replacement, what is the minimum number of draws required so that the probability of drawing at least one blue marble is more than 0.7? Okay. For this, simply see probability of drawing a red marble is 3 by 5. So probability of drawing a blue marble is 2 by 5. But we are not looking for probability of drawing a blue marble. We are looking for probability for drawing at least one blue marble. At least one blue marble. So if there here, what comes to our rescue is look at the options. The options numbers are nice. 1 minus all red. If I do, I have to ensure the probability of 1 minus all red is greater than 0.7, is greater than 0.7, or can I say probability of all red has to be less than 0.3. Probability of all red has to be 0.3. So if there were two marbles, there were two drawings are happening, both of them being red, the probability is 3 by 5 square. Just checking for option D. 3 by 5 square, which is 9 by 25, which is equal to 0.36. No, this is not enough. We wanted less than 0.3. Let me check option C. 3 by 5 whole cube will get us to 27 by 125, which is equal to into 8. 0.216. And yes, this is indeed less than 0.3. And therefore, the answer to this question is option C. Otherwise, see, this is the smart way of doing it. Otherwise, you will go into dark web of let's try to solve this using what is known as binomial theorem and everything. Directly, this way is the best way of solving. Okay, next. In a defective sixth-faced die with numbers 1 to 6 inscribed, the probability of getting an odd number is twice the probability of getting an even number. Find the probability of getting a 2-digit prime number on adding 2 successive throws of the die if among the even numbers all are equally likely, and same is true for odd numbers. Okay. First thing I'm listing out 1, 3, and 5 are the 3 odd numbers. 2, 4, and 6 are the 3 even numbers. Now we're told probability of getting an odd number is twice the probability of getting an even number. So probability of these 3 combined is 2 by 3. Probability of these 3 combined is 1 by 3. Now we are also told each of them are equally likely. So probability of each of them is 2 by 9, 2 by 9, and 2 by 9. And probability of each of them is 1 by 9, 1 by 9, 1 by 9. Okay. Now, see, if we are looking now, find the probability of getting a 2-digit prime number. The maximum sum you can get is 12. The second highest sum you can get is 10. The third highest sum you can get is 9. And after that, all single-digit numbers will come. So a 2-digit prime number that is only available is 11. So we either need a 6, 5 or we need a 5, 6. One of these two cases needs to happen. Either a 6, 5 or a 5, 6. Okay, let's go it for 6, 5. 1 by 9 into 2 by 9 plus 5 and 6 will be 2 by 9 into 1 by 9. Altogether, we'll get 4 by 81, or option B is the right answer. Next, a coin of radius 3 centimeter is dropped on a square floor full of square shaped tiles, so side 10 centimeter each. Okay. This is a former year XAT question. It's a fun question. Okay. What is the probability the coin will land completely within the a tile? Now see, the coin has to be completely within a tile. I will make a diagram outside. What needs to happen is, at best, it can be tangential to the two sides. Yes, something like this. At best, it can be tangential to the two sides. So look at the center of this circle. Sorry, center of the circle. Yes. Can you see the center has to be at least 3 centimeters in from the left hand side boundary. Additionally, not only just from the left hand side boundary, it also has to be 3 centimeters in from the right hand side boundary. It also has to be 3 centimeters in from the bottom, and it also has to be 3 centimeters in from the top boundary. Can you see the center of the coin can only be present within this 3 on 3 on within this 4 by 4 square? The center of the coin that is being dropped can only be placed within this 4 by 4 point, because if it is outside this 4 by 4 point, the coin will go outside the tile, and we are seeking probability coin will land completely within the tile. So our favorable probability is 4 into 4 by 10 into 10. The entire area of the square divided by the coin or the center of the coin landing within this 4 by 4 square, which is equal to 0.16, or option D is the final answer. Next question. A rectangle is drawn such that none of its sides has length greater than A. All the lengths greater than A are equally likely. The probability that the rectangle has its diagonal greater than A is. Okay. Again, first thing we'll do is we'll draw square. See, if this is A, this is A. I'm drawing a quarter of a circle here. These are all any a rectangle is drawn such that none of its sides has length greater than A. All the lengths greater than A are equally likely. The probability that the rectangle has diagonal greater than A. Can you see all the rectangles for which this is one side, and the opposite vertex to this lies on this arc will have its diagonal equal to A only. This will have its diagonal equal to A only. And all the rectangles where the opposite vertex to this is within this range will have their diagonals outside, will have its diagonal greater than A. So if we are looking for a probability that the rectangle has its diagonal greater than A, we are essentially looking for this area upon area of a square outside quarter circle divided by area of square. This is what the question is asking. I don't know if it is entirely clear, so I will try to explain it once more. See, this is the maximum length. These are the maximum lengths that you can potentially have of the rectangle. Two sides can be at max A and A, in which case it will be a square. Now, let's say if this is one of the vertices and you pick one more vertex here, here it's the rectangle, you can create this rectangle. This will have the diagonal length here is A. So this is an unacceptable case because we were looking for a diagonal greater than A. We could also potentially take any point within this. The diagonal is smaller than A also. The diagonal here is smaller than A also. But up until what point are the diagonal length A or less than A? It is only within this arc, it is only within this quarter circle. Any point outside of this quarter circle, you will get your diagonal lengths. Let's say this is a point, a rectangle like this is made. The two sides of the rectangle are clearly not A, yet the diagonal length is greater than A. The diagonal length is greater than A. So any point outside this quarter circle in this region, these are favorable. This area is favorable. The one that has been marked in green. And everything within this arc is unfavorable. But both of them together make the universe. So in order to reach the answer here, we need area of the square outside the quarter circle divided by the area of the square. Area of the square is very simple. It is A square. Area of the square outside the quarter circle is A square minus, this is the radius of A, so pi A square pi 4. We can remove A square from everywhere. We'll get 1 minus pi by 4. Or the correct answer to this question is option C. This is a very, very nice conceptual question to wrap it up, because this requires thinking in an unconventional way, which is not very common. Additionally, this is the last topic based. From next week, 2 or 3 weeks, we will have a mixed bag based questions coming up. Hopefully, we are prepared for that. See you next week. Goodbye.